In this video, I'm going to show you how to integrate a linear function in a bracket raised to a power. Okay, so when we were differentiating this, we saw that we could do this with the chain rule. So I'll show you how to use that in reverse in order to integrate. There are two distinct cases here. We have one where r does not equal -1, which is the fairly straightforward one using the chain rule. And then we have the case where r does equal -1. And we'll look at that separately and do some examples on each just to make sure they're really clear. So for the first one, we're assuming that r does not equal -1. So basically, this is not the case where our function is 1 over ax plus b, because that's something a little bit different. Okay, so what I'm going to do is show you how we would differentiate this function using the chain rule, and then how we can kind of work that backwards in order to integrate this function here. Okay, so using the chain rule, we've got f of x is a times x plus b to the power of r plus 1. So we know that we're going to kind of pretend that everything in this bracket is just our variable. So we'll bring the r plus 1 down, multiplied by the ax plus b, and then reduce this by 1, which just gives us r, and then not forgetting that we then need to multiply by the derivative of the function in the brackets. In this case, it's just a. So we get a outside r plus 1, ax plus b to the power of r. Now, what we want is that the derivative is just this part. Okay, this ax plus b. So in order to get to that, we need to multiply the whole thing by 1 over a to the r plus 1. So basically what we said is 1 over a to the r plus, a times r plus 1 times f of x. Okay, so this is a scalar multiple, which means that we can then say, well, if we're multiplying the derivative by 1 over a r plus 1, then we can also multiply the original function. So we can have, that can lead to 1 over a times r plus 1 times f of x. Now we've said that f of x was this function up here. Okay, so therefore f of x is going to be 1 over a r plus 1 times ax plus b to the r plus 1 there. And of course we must remember plus c. Okay, so just to formalize that, what we're saying is that if we are integrating ax plus b to the power of r with respect to x, then that will give us 1 over a r plus 1 ax plus b to the r plus 1 or plus c. Okay, and if you differentiate this using our chain rule, then you'll see that as you bring this down over here and then you multiply by the derivative here, that cancels out, and what you end up with is our ax plus b to the power of r, which is what we're looking for. So let's do a couple of examples, because nothing's better to help you understand this than doing some examples. So the first one, for a, integrate 3x plus 1 to the power of 5. Okay, so that's going to be, we want 1 over a, which is 3, times r plus 1, which is 5 plus 1, times our original 3x plus 1, and increase the power to 6, okay, plus c. And then simplifying, it just gives us 1 over 18, 3x plus 1 to the power of 6 plus c. Okay, so pretty straightforward. And then b, exactly the same, doesn't matter that it's a negative index there. So same thing, we start with 1 over a is 2, negative 1, so that's r, negative 2 plus 1, times what we had in the brackets, 2x minus 1, increase that power by 1, or plus c. Okay, and then just simplifying, that gives us negative a half times 2x minus 1, so negative 1, plus c. Okay, so just bearing in mind the formula for that you're just multiplying by 1 over a outside r plus 1, and then same process, increase the power by 1, and don't forget to add c. Okay, now this is the interesting case. So we're saying when r does equal -1, which means the function is 1 over ax plus b. Okay, now in order to do this, we should be looking at that and thinking, oh, that looks a little bit familiar from when we did our work with natural logs. Okay, so recall that when we worked with natural logs, we had natural log of x or natural log of ln x, and the integrals of both of those, sorry, not the integrals, the derivative of both of those was 1 over x. So it didn't matter if it was ln x or ln of minus x, it was still 1 over x. So when we do that in reverse, we can say, so in reverse, we can say that y is ln, and we use absolute value of x, which just says it doesn't matter whether x is positive or negative, we just treat it like a positive. Okay, so that kind of captures this, whether this is positive or negative, because the derivative is the same for both. Okay, so just a quick word on absolute values. So the absolute value of a number is simply the distance from 0. So if you go back to sort of year 7, think about the number line. The absolute value is just the distance of that number from 0. Distance is always positive. Distance doesn't, you can't have a negative distance. Okay, distance is positive, so therefore the absolute value of x is the same as the absolute value of negative x, and it's just x. So nicely illustrated here, absolute value of 5 is 5, the absolute value of negative 3 is 3, and the absolute value of 0 is 0 because it's 0 distance from itself. Okay, so that's just a quick aside on absolute values. So whenever you're integrating 1 over x or 1 over ax plus b, you need to start thinking about absolute values for the natural log. Okay, so to apply this for our integration, so remember that if we had ln, if y was ln of ax plus b, remember that the derivative of that was a over ax plus b. Okay, so therefore if we're doing it in reverse, and what we're actually looking for is we want the integral of 1 over ax plus b. So it's a little bit different because we don't have this a. What this basically is saying was this is we want to divide by that a to get rid of that afterwards. So we're going to say 1 over a times ln, and using our absolute value, ax plus b. Okay, and already remembering plus c, and if you differentiate that, you end up with your a over ax plus b, and then the a's on the top and bottom cancel out, and that gives you your 1 over ax plus b. Okay, so that's our form for integrating 1 over ax plus b. And if you have something other than 1 here, you just kind of pop it out the front and then multiply it back in afterwards, which I'll show you in just a second with our example. Okay, so for this one, find the general antiderivative. So we want to integrate 2 over 3x minus 2 dx, but that must be 1 on the top. Okay, so what we can do is pull that out and say, well, that's the same as 2 outside. So 2 times the integral of 1 over 3x minus 2, which is much better. Okay, and now we just proceed as always. So 2, just leave that. 1 over a is 3, so 1 over 3 times ln of 3x minus 2 plus c. Okay, and to just tidy that up a little bit, 2 over 3 times natural log absolute value plus c. Okay, so there's a little bit going on here. It might take you a little while to sort of get your head around this one, so do make sure that you go and practice, do some exercises out of the book, check your answers. If you're not sure, come back, have another look at the video. Okay, because there's a few sort of things to remember here with your plus c's and your integration of this this form, and then the absolute values of the natural log and so on. So let's do another one. Okay, so this is one where we've been given some information about the curve itself, which means we should be able to find the constant. Okay, so firstly what we're doing is trying to integrate 2 over x. Again, we want that to be a 1 on top, so take the 2 out, 1 over x dx. Okay, that's the integration of that will give you natural log of the absolute value of x plus c. Okay, and now what we want to do is solve. So we know that when that's 1, the value of this is 10, so you can say 10 is 2 times ln 1 plus c, and of course ln 1 equals 0. This one equals 0. So in order to solve that, you'll then have c equals 10. So therefore, expression for y in terms of x, y equals 2 ln absolute value x plus 10. Okay, and you can do this on your class pad. So we wanted 1 over x, and we're saying please integrate that. Okay, it's indefinite at this point, so it gives us, and you can see it actually gives you the absolute value there, so ln of absolute value of x. Now if you want to solve this, oh sorry, that should have been 2 over x, not 1. So it gives you 2 ln x, which is what we had here. Now if you want to solve it, you need to drag that down. You need to say that there's plus c, and we want to change that to 1 and say that it equals 10 because they're the points that we've been given, and now you can solve using your interactive and just make sure that you change the variable to c. Okay, and it will give you c equals 10. For a problem this simple, you wouldn't do it like that. You don't need to. It'd be quick to do it in your head, but if it gets more complicated, or you're doing a check, so doing it in your head first then checking, that's how you do it. Okay, so that just summarizes our integration of the form ax plus b to the power of r. Okay, so as long as r does not equal -1, then this is the form that you follow. So 1 over a times r plus 1, and then ax plus b to the power of r plus 1, always plus c. Okay, and remember at any point, if you get stuck, differentiate to check. Alright, that's always the easiest way to make sure that you're getting it right. For the special case where r doesn't equal -1, then we're looking at an integration to a natural log using absolute values and just making sure that you're dividing by that a so that you end up with this 1 here. Okay, absolute value means the positive value, so that takes care of any whether that's positive or negative, and then you substitute in the given point if you're trying to find the value of c. Okay, and that's what we did in the us example.